Let us see one more problem on nodal analysis. What is the question given? Find V1 and V2 in the circuit using nodal analysis. So what he asked to find? He asked to find V1 and V2 using nodal analysis. By using normal nodal analysis, this problem won't solve because this two source affects while solving the problem. So we are using supernode concept. In supernode concept, what is supernode? This is a supernode. This is a supernode concept. We are removing this voltage source and writing the equations. Here this supernode is named as here V1 and V2 taking as single node, such that we are tying V1 and V2 together and writing the equations. If we draw the circuit from here, this look like this. Here this 10 ohms is from single node, it is connected, so this won't make any sense, so we are removing this 10 ohms. So if we redraw the circuit, this look like this. So the circuit is look like this. So now apply apply KCL at node 1 and node 2. We are taking node 1 and node 2 as single node. So while we are applying, we are taking current flowing away from the node. So the current directions look like this. Let us name this as I1, I2 and I3 and I4. Then from KCL, sum of currents incoming to the junction is equals to sum of current leaving from the junction. Here there is no incoming current, so 0 equal to all are outgoing. So I1 plus I2 plus I3 plus I4. If we rewrite this look I1 plus I2 plus I3 I4 equals to 0. Now what is I1? I1 flowing opposite to the direction of this 2 amp source, so minus 2 plus there is no I2, so we are taking I2 equivalent from Ohm's law. So here from Ohm's law, if we write I2, then we get V1 minus this ground source. So here there is no potential, so V1 minus 0 by 2 ohms plus there is no value of I3, so we are taking I3 equivalent. Now I3 equivalent from Ohm's law, we get V2 minus this ground voltage. At ground voltage it is 0 volts, so V2 minus 0 by 4 plus what is I4? I4 is current which flowing along to the direction of the 7 amp source. So I4 is equals to plus 7, which is equals to 0. Add constants, so we get 5 plus V1 by 2 plus V2 by 4, which is equals to 0. On taking LCM, we get 4 as LCM, so 4 4 4 equals to 0. So 1 by 1 into 4 4, 5 into 4 20, 2 into 2 4, so 2V1, simply 4 into 1, so V2 into 1 V2. So taking 4 as common and sending to other side, so 4 get cancelled. Now we are left over with 20 plus 2v1 plus v2 equals to 0. Now if we rewrite, we get 2v1 plus v2 equals to minus 20. To solve this equation, we need one more equation with v1 and v2. So we are taking, so we need one more equation of v1 and v2. So we are considering this voltage source. Now it's in supernode, we have to use a KVL equation on this supernode. So we get, if we apply KVL in this loop, then we get, apply KVL on v1 2-volt source and v2 loop, then we get, here current flow direction is, here current flowing such a way, current flowing in this direction. So from current directions, if we apply KVL, this v2 is flowing along with the current direction, so positive v2, and this is coming opposite to the direction of this loop current, so minus v1, and this current touching to first negative terminal of the voltage source, so minus 2, which is equals to 0. So minus v1 plus v2, which is equals to 2, or take minus as common, then v1 minus v2, which is equals to minus 2. So consider this as equation 2. Solving equation 1 and 2, we get v1 and v2. We get v1 equals to minus 22 by 3 or minus 7.33 volts, and v2 equals to minus 16 by 3, which is equals to minus 5.33 volts.